Hello there, this is Coach Ikram, and welcome to this add-on video for acids and bases. In this video, we are going to be specifically discussing titration curves. If you remember, just some basic definitions and vocabulary associated with titration curves. Remember, on a titration curve, we have what's called an equivalence point. It is the point of neutrality in a titration. For an acid-base titration, it's when your number of moles of your hydrogen ion concentration equal to the number of moles of your hydroxide concentration. Your endpoint is the point at which the indicator used in the titration changes color. Remember, the endpoint isn't necessarily the equivalence point, but you want them to be as close as possible. Another important thing to understand is the concept of a buffer or a buffer region. A buffer is a solution that can resist pH change upon the addition of an acidic or basic component. So if you take small amounts of added acid or base to a neutral solution, the buffer can maintain the pH of that solution and keep it relatively stable. So for example, blood is a really good example of a buffer in your body. You can take in things that are slightly acidic or slightly basic, and blood is enough of a buffer that it can neutralize those acidic and basic things and keep your body from changing pH and keep it stable. So we're going to show a curve here that's going to actually show what's happening when I titrate a strong acid with a strong base. So, for example, I've got my pH over here, 0 to 14. I've got my volume of NaOH down here at the bottom. So you note that my pH starts very low, which means it's a strong acid. And I'm going to add a strong base to it. So as I add my base, we've got kind of a slight buffer region here, and then you'll notice it takes a dramatic curve up. And this space right here is only a matter of a few drops in a titration. Okay, if you notice over here, like this is my milliliters, I had 24 milliliters, 25 milliliters, 26 milliliters, boom. And then all of a sudden I was a very strong basic solution. If I used bromesqual green indicator, you'll notice that its endpoint is down here with an endpoint of about 5. And if I use phenolphthalein, you'll notice that my endpoint for phenolphthalein is a little bit higher. My equivalence point, though, technically is right here in the middle, and that's going to be an equivalence point of 7. So this is a strong acid titrated with a strong base. So it starts off acidic and ends basic. If I have a weak acid titrated with a strong base, notice here we've got a very gradual ascent, and we've got a very large buffer region right here. And you also notice that my pH of my acid starts off a little higher because it's a weak acid and not a strong acid. But it is still a strong base. And so you'll notice here also another observation that phenolphthalein, its endpoint is closer to my equivalent point. Here, I'm going to titrate a strong base with a strong acid. Note here, I'm starting with my base. So my solution, it's basically the opposite of what we just saw. We're starting with my basic solution. I've got a fairly gradual buffer region right here, and then I shoot down in a matter of milliliters past my equivalence point, and I end up with a low pH and a strong acid. So this is strong base and strong acid. So if you titrate a weak base with a strong acid, you should notice it also kind of follows that same pattern as we did when we did weak acid, strong base. It's still the same basic shape, but you have much more of a buffer region, a gradual kind of descent, and then your equivalence point is actually going to be less than 7. It's going to be down here between 6 and 4 at about 5.27, and that should make some sense because you've got a stronger acid here than a base. And also note that it's a weak base, so it starts between 10 and 12, and that's going to be slightly weaker because it has a slightly lower pH. So comparing the titration curves is sort of essential to understanding what's actually going on. So here I've got a weak acid and a strong acid, so you can kind of see the difference between the two, where they start in the pHs. And so you can kind of see that buffer region, and they're both being titrated with a strong base, so note that they do end up at the same point. The weak acid has more of a buffer region, and it's more gradual, whereas the strong acid is going to be more dramatic with that. Same with strong base and weak base. So my strong base starts up here, my weak base starts a little bit lower. Their equivalence points are also important, and it's important to note the difference between the equivalence points of the two. So if I've got a weak acid titrated with a strong base, my equivalence point is actually between 8 and 10. And if I've got a strong acid over here, my equivalence point is actually between 6 and 4, because it's going to be a stronger acid, so the pH is going to be slightly more acidic.